Welcome for mathematics lesson. We're going to discuss longitudes and latitudes. Number 23. A ship sails from point A, which is 0 degrees, then 70 degrees west, due north, to B, 25 degrees north, 70 degrees west. Then due east to C, 25 degrees north, 12 degrees in the east. And finally, a further 1,800 nautical miles due east to D. Part A, calculate the total distance covered in nautical miles. Let me begin by sketching the positions of the 4 places. So this is 0 degrees prime meridian, 0 degrees equator. So this is 0 degrees equator. This is a 0 degrees prime meridian. Now the first place A is 0 degrees equator, 70 degrees in the west. So 70 degrees in the west. We are having a place here called A. Now a ship is going to sail from 0 degrees, then 70 degrees west. This is 70 west, to the north until it reaches B. And you know B now is 25. B is 25 degrees in the north. So this is where B is. That is where B is. Then we are told that due east. So from B, due east until it is 12 degrees in the east. So along this latitude until 12 degrees east. So this is 12 degrees east. This becomes our C. 12 degrees in the east. Finally, a further 1,800 nautical miles due east to D. So it continues moving until it is at a point D, which position is not known. Therefore, now we can calculate first of all the distance, as we are told to do. From A to B, the distance in nautical miles is usually given by, because this is a great circle, distance will be 60 multiplied by theta, and this is difference in latitude. Therefore, 60 multiplied by, from 0 degrees equator to 25 degrees north, we'll have an angle difference of 25. Therefore, the distance in nautical miles will be 1,500. That is nautical miles. Then we have B to C. B to C, the distance is now in a small circle. 60 times theta, the cosine of the latitude where the 2 places are. Therefore, 60 multiplied by change in longitude from 70 degrees in the west to 12 degrees in the east. These are longitudes on opposite sides of the prime meridian, and therefore we add the longitudes to know the angle difference. So from 70 to 12 on the other side will be 70 and this 12. So this is going to be 82 multiplied by the cosine of latitude 25. Therefore, the distance is going to be 60, 82, the cosine of 25. This is giving us 459.03 nautical miles. And finally, we have from C to D a distance of 1800 nautical miles. Therefore, total distance now can be calculated, whereby we simply going to add plus the first distance there, which is 1,500 Therefore, the total distance is going to be, when we add, this is going to be 7,759.03 nautical miles. 0.03 nautical miles. Then we are told in part B, if the whole journey took a total of 300 hours, find its average speed in knots correct to 1 decimal place. Therefore, speed is given by distance out of time. For the speed to be in knots, we need distance in nautical miles. So 7759.03 divided by 300 hours. This is going to be 25.86, and to 1 decimal place it will be 0.9 knots. So that is going to be the speed in knots for the given journey. Finally, we are told to find, to the nearest degree, the final position of the ship. Now, final position, because we've been told that from C to D it's 1,800 nautical miles, we can get the angle difference from C to D. Now that distance is given by 60 multiplied by change in longitude, the cosine of latitude, then we will say the distance of 1800 equals to 60 multiplied by the angle difference, cosine of latitude, 25 degrees. Therefore, we can get the angle difference or the longitude difference from C to D. And this is going to be, we divide by 60, the cosine of 25. This is giving us 33.10 degrees. Therefore, from C, which is 12 degrees in the east, we are going further to the east by adding 33.1 degrees. And that is going to take us to, when we add 12 here, we're going to have 45.10. To the nearest degree is going to be 45. Therefore, position now is going to be, position of D, 25 degrees in the north, 45 degrees in the east. So this will be the position of the ship finally. Thank you for following, subscribe and share.